Welcome everyone. Today's lesson we're going to be looking at two different topics really. We're going to look at how do we solve linear equations to start, a little bit of a review from your course grade 9 and 10. And then the second part of the lesson we'll be looking at how do we solve quadratic equations today by factoring. So you'll learn that there's two different methods that we'll focus on when solving quadratic equations, but today we'll look at the method of factoring. So once again, just the same with the other videos, if you want to stop the video and try the work on your own and then start the video again and see if you've come up with the same answers as I have, that is a good way to check your knowledge and understanding of the concepts as we go over the lessons. So first off, linear versus quadratic. So first off, if we want to solve something, we have to understand if the equation given is linear or quadratic. So take a look at the following functions and classify them as linear, quadratic, or neither. So once again, this could be a good point for you to stop the video, give them a try, and then start the video again once you've tried to answer them on your own. So let's look at A. I notice that X is degree 1 and Y has a degree 1. If they're both degree 1, I know this is linear. When I look at B, I know the Y is degree 1, and here's my X. It's right here, and it has a squared outside the bracket, so it's degree 2, and that's how we define a quadratic. The next one, the X is degree 2, and the Y is degree 1, so this is also quadratic. Here we have square root X. So that's not a degree 1 or degree 2, so I know this is neither. The Y here is degree 1, the X is degree 1, so this would be linear. F, we notice that it is a cubic, or it is degree 3, so this would be neither. So let's just summarize what we're looking for in an equation to determine if it's linear, quadratic, or neither. If both the X and Y variables are of degree 1, the function is linear. Graphing this function will produce a line. Remember, that's how we start linear, line. If the X variable is of degree 2 and the Y variable is of degree 1, the function is quadratic. Graphing this function will produce a parabola, and we learned this in the previous unit, that it is a parabola. Sorry about that little A. So let's first start now with reviewing linear equations. So what do linear equations look like? So some examples of linear equations might be x add 3 equals 12. Maybe we have negative 2x plus 3 is equal to 14. We could have x add 3 is equal to 2x add 6. These are all forms of linear equations. Remember, an equation is different than an expression because it has the equal sign in it. And we can solve these, right, because there's only one unknown variable. When solving linear equations, the goal is to isolate the variable. Or you could say this as find the value of the unknown variable. So we're looking in these cases, what is x equal to? That is our goal. Remember, when solving linear equations, we would first, one thing we want to do is use BEDMAS to simplify each side of the equation. Right, so we would remove our brackets. Using distributive property, we might have to collect some like terms. Then after we have simplified each side of the bracket, we want to collect like terms on opposite sides of the equal sign. What I mean here is we'll move, usually I do move variables to the left and constants to the right. So a little example of that might be if I, just a simple example, 3x and 2x subtract 1, I would move my 2x over here and I'd move the 3 over there. That's what I'm saying. And then we would just collect those like terms. So we want to make sure we get the like terms, and then we'll just simplify after we have those like terms collected. Solve the following linear equations using techniques you have learned in the past. So this might be another place to stop the video and try these on your own. Once you've tried them and answered these questions down here to the bottom in conclusion, then you might want to start the video again and see what we have come up with as a solution. So, exercise. Solve the following linear equations using techniques that you have learned in the past. So, first off, remember we're going to use BEDMAS to simplify each side, so we would use our distributive property to remove the brackets. Then I notice on this side I have some like terms, so I can collect those like terms. Sorry, this should be 16. And then I want to collect the like terms. So the x term will stay on this side, but I'm going to take the constant and I'm going to bring it to the other side with the 16. Remember, when you bring it over, you change the sign. So now I have 7x, 16 and a negative 23 would be negative 7. And then I'm going to divide by negative 7. So my x is equal to negative 1. That is the solution to that linear equation. Let's try the next example. Once again, we're going to remove the brackets. I'm going to simplify on this side by collecting the like terms. I notice I have x terms, so a negative 2 and a positive 5. That would give me 3 x's on this side. Sorry, bad choice of pen. And I also notice I have constants on this side, which equal negative 26. So this is where I want to bring my variable term. I want to leave it here on the left side, and I'm going to take this constant term and bring it over to the other side. So 3x is equal, don't forget to change the sign. So I have 3x is equal to 27, and then I'm going to divide by 3 to get 1x, so x here is equal to 9. How do we know that the previous two questions are linear? So remember, how do we define they're linear? We know that we are able to isolate for the variable. Let's try to solve a quadratic equation now. Solve the following quadratic equation. First off, how do we know that this is a quadratic equation? Well, we know it's a quadratic because we have degree 2 here and degree 1. So we know the x variable is degree 2 and the y variable is degree 1. Try solving the equation. So let's just rewrite the equation here. Remember, the goal up here is to isolate for the variable. Can we isolate for x when we have an x squared and an x? We can't, right? There's no way to isolate for the variable. So in conclusion, we cannot isolate the variable when solving quadratic equations. So we're going to have come up with another method on how we solve quadratic equations, and that is our second part of our lesson. So here we go. Sorry, put this down far enough. Solving quadratic equations. Some examples of quadratic equations. We know we've had different forms of the equation from our previous roots. So let's just look at what if we have an equation that looks like this. Or maybe we have it in standard form. Or maybe it's in factored form. These are all examples of quadratic equations. When solving the quadratic equation, the goal is to find you can call them zeros, x-intercepts, or roots, maybe, of the equation. We can do this. There are two methods we're going to learn. We can do that by factoring, which we're going to learn today, or by the quadratic formula. Which we will save for next lesson. So let's look at the steps we'll need in order to solve quadratic equations using the factoring method. So step 1, simplify both sides of the equation as much as possible. 2, we're going to bring all terms to one side of the equal sign. The other side must equal 0. So all the terms will be on one side equal to 0, and we'll have them in the form of standard form. So it will look something like this. Factor the side with all the terms. Set each factor or bracket, because they'll be in brackets, to 0 and solve for the desired variable. Because in the brackets, we'll just have a linear equation or expression in there, and we're able to solve that. So let's follow these steps and do our first question. Number 1, simplify both sides of the equation as much as possible. So I look at both sides. There's two terms here. They're not like terms I cannot simplify. And there's only one term here. So there's nothing I can simplify for this one. Bring all the terms to one side of the equal sign. So I have my x squared term here. I need to bring this term to the other side, and because it's the x term, it will go in between the constant and the x squared term. Don't forget, you're changing the sign when you bring it over. 3, factor the side with all the terms. So we have a trinomial here, so we know trinomial factoring. We'll set up our brackets. Since this only has factors of 1, I know the first part of the bracket will be x and x. And the only factors of 3 are 3 and 1. And since this is a positive and that's a positive, I know I would need an addition sign in each bracket. Set each factor or bracket to 0. So I'm going to write down the expression in this bracket and the expression in this bracket, and I'm setting them equal to 0. I can solve for the variable here. So I have x is equal -3 or x is equal -1. That is my solution. What do these values represent? These values represent the x-intercepts. So if we were to graph this, we know that the parabola will cross through the x-axis at -3 and -1. Let's look at our next example. First, simplify both sides as much as possible. We cannot simplify this. Bring all terms to one side. So I'm going to bring this term to the other side. Remember changing the sign as I bring it over, and then that will be equal to 0. 3, factor the side with the terms. So I'm going to factor this. So I notice both have an x term, so I'm going to factor out the x. Then I have to set both factors here to 0. So I'm going to set x equal to 0 or x minus 4 equal to 0. So I have x is equal to 0 or x is equal to 4. Though that is my solution to this quadratic equation. The next one, there's nothing to simplify on this side because I have no like terms. It's already equal to 0. So here I'm just going to be factoring the equation. We have a complex trinomial, which you guys have practiced in the previous unit and had a bit of factoring review at the first of this unit. Since I have a 2 here, I know the only factors here for the last one are 2 and 1. And remember, I usually pick the factors that are closest together. So I'm going to pick 2 and 3. Once again, I cannot substitute the 2 in here because I'd have a common factor. So I know a 2 could go here and a 3 here. And then this produces 4 and this produces a 3. So I need a negative. So I know my larger integer would have to be negative. So the 4 would be negative and the 3 would be positive. Once again, the next step is to set each bracket or factor equal to 0. And then I'm going to solve. So I'm going to bring this to the other side by changing its sign, and then I'll divide by 2. That is one of our solutions. I'll bring this to the other side by changing its sign, and then I'll divide by 3, and this is the other solution. D. Once again, I'm going to there's nothing to simplify on each side, but I'll bring this to the other side, changing its sign. And I know I can factor this. This is a difference of squares. Once again, you should have been practicing these in the previous video. So square root of the first term, square root of the last term, different signs in each bracket. And I'm going to take each expression in the bracket, set it equal to 0, and I will solve those equations. Our last example. Remember, it's always good to try some of these on your own and come back and check and see if we've gotten the right answer. So here we can see we have a few brackets. One is squared, one's not squared. So we have a bit to do on our first step this time when we need to simplify both sides. Remember, this is a perfect square trinomial. You can write the two brackets and then multiply them together using FOIL. Or if you remember, it's just, I'm going to square this term, multiply these two together and double it. So I'll have 4m, and then I'm squaring the last term. For this one, I'm going to distribute into the bracket. So I want to simplify on this side. So I need to determine my like terms. So I have an m term here an m term here, and I also have my constants, so I'm going to combine those on the next line. So I have 11m, and a positive 4 and a negative 14 is negative 10 is equal to 2. Step 2, we need to bring all terms to one side and make it equal to 0. So I'm going to bring this over to the other side. So I'll change the sign. And then I'm going to collect these like terms. Now that I have it in the standard form, the squared term, the m term, and then the constant, I know I can factor. This is a trinomial, so I'm going to set my brackets up for a trinomial. The only factors here are 1, so I would put an m in each bracket. And then I need the factors of 12. Once again, usually I pick the ones closest together, but I notice this is 11. So I know right off that 12 and 1 are going to be the ones that work. So I put 12 and 1. It has to be a positive 11. So I know my larger integer has to be positive and my smaller integer will be negative. And then I'm going to set each bracket equal to 0 and solve. And so my solution to this one is m is equal to 1 and m equal to negative 12. So just to summarize, to find the solution to a quadratic equation, we have to actually find those zeros, roots, or x-intercepts. And we do that by, in this method that we learned today, by factoring.